We're going to be talking about generative STEM as a mathematical framework. So the generative in generative STEM means the recursive loop, the self-generating power of life. And that's essential to what scientists have talked about in terms of negative entropy, in terms of life as a self-organizing system, but it's also deeply embedded in African traditions. We see here the example of generative justice in the Adinkra economy. So we produce a bark from a tree, it gets boiled and turned into ink. That goes into the cultural commons, and the leftovers, the waste, goes back into the forest and contributes to biodiversity that produces the tree. So it's circulating ecological value, it's circulating labor and social value because it's going into a commons, so all can share and all can take as well as give. So these are circulations of unalienated value, value that's not extracted and carried off somewhere else. Unfortunately, that's exactly the way both corporate and state enterprises have worked. They've created technologies to extract that value and take it somewhere else. So the idea of generative justice, of a generative economy, is to use something like organic agriculture to circulate ecological value, or worker-owned platforms to circulate labor value, or free speech and free expression, open source code to circulate expressive value. And science and technology are crucial in restoring those forms of generative justice. So that's what generative STEM is all about. Of course, the roots of the extractive economy have everything to do with colonialism and the fact that they created this imaginary scene of the pyramid in which there's higher civilization at the top and lower primitive cultures at the bottom. So in order to restore that generative economy, we have to decolonize STEM to recover some of those heritage algorithms. Great way to do that is with African fractals. So here we have a fractal structure in southern Zambia. You can see it's a circle with the sacred altar for a house, the circle of circles for the corral, and the village as a whole is a circle of circles. So you've got that kulia is the term they use, that embracing or nurturing of each scale. And that can be seen all over Africa. In the symbol, the snake biting its own tail is an abstract representation of that idea of self-generating cycles. Our first attempt to do this was to use cornrow hair braiding so that African American children would recognize the fractals as part of their own culture. This uses just mathematical parameters, but that's now turned into a programming interface, a scripting interface. The kids can learn some computer science as well as mathematics. We've done controlled studies. One group has the culture-based version, one group has the same software without any culture. And you can see statistically significant improvement for the children using the culture-based version. And we've done that in Africa as well, so not just in the US, but all over the globe, children benefit from having a culture-based version of math and computing presentations. We have a very specific process we go through to make sure that the material is being used in a respectful way, that we have cultural permission, that we're really representing the way local people think about it. We're not just imposing our ideas about what mathematics is there, and that these are embedded in design tools that the children can use in creative ways. So our website is Culturally Situated Design Tools. It includes simulations that the children can use for indigenous culture as well as vernacular culture, graffiti, breakdancing, skateboarding, anything that they feel a sense of cultural ownership over. This is what the website looks like, csdt.rpi.edu, open source, open access, anybody can use it without any cost. Sometimes the children create critiques, so it's not always a happy story they want to tell us, but they're learning math and computing when they're creating that simulation that provides a critique. So it's a win as far as I'm concerned. We try to bridge these virtual worlds with the physical world. So my colleague Audrey Bennett in University of Michigan works with art teachers So once the kids have their virtual design, they can physically render these creatively as artistic endeavors. We work with folks in sports science, so the children are creating their own ergonomics laboratory to measure their ability to jump and run and dribble the ball. We work in areas like sustainability, so the children are creating their own sensors and running their own experiments in urban farming and sustainable dyes for fabrics. So the wrong way to think about culture-based STEM is to view the students as little rats and culture as the cheese that we tempt the rats through. That's not at all what we're trying to do here. It's really about expanding cultural agency, about exploring heritage algorithms, creatively making physical renders, and then interacting with the community as that last stage of engagement. And so here's some examples from indigenous students in Detroit, Michigan, and in northern Michigan, the Anishinaabe, measuring temperature in the Detroit River, creating aquaponic systems, planning out how that could empower their community. So we want not to diversify just the input to the STEM pipeline, because that will just produce the same old, weapons and pollution. We want to refashion the pipeline as a cycle, this cycle of generative STEM. So the value that's created through science and technology goes back to those communities. So here's an example in braiding shops in Albany, New York. Here's another example of the same idea in the village of Ntonso in Ghana, where students from Kwame Nkrumah University have worked with us to create a DIY condom vending machine for HIV prevention, solar power for boiling that bark into ink. So you have this circulation of ecological value, of social value, moving through as a cycle rather than a one-way extraction. And it's even entered into global Africa, the African diaspora. Here you have a fractal layout of a university in Ethiopia, Black science fiction writers talking about fractals and coding information into cornrow braiding, fractals in the Caribbean culture in Erna Brodber's novel. This is a conference in Canada. So lots of places have taken up this idea of heritage algorithms and just used it for all sorts of creative purposes. February 1st, we'll be launching some AfroFuturist pop-up shops. So we'll be training folks in the use of these simulations, in digital fabrication tools, and then hopefully getting some commercial products out there to be marketed and to benefit these low-income communities. And I hope folks will be interested in going to our website or perhaps even joining us in the pop-up shop endeavor. Thank you.